Hi there! In this video, we're going to be looking at something called compound Boolean expressions. And to demonstrate them, I've pulled up the driver's license example from the previous video. So this is my solution to that practice problem. It's got my header comment. It says this program determines if the user can apply for their license. We're including our standard input and output library. And we've defined the age limit for being able to apply for your license as 16. So it's important for us to remember to use constants when it's appropriate. In this case, there's a well-known limit, age limit, for when you can apply for your license. But having it set up this way also allows us to change it really easily if we wanted to modify our program for a state where the limit was maybe 18 instead of 16. We could change it in just this one location and it would still work with the rest of the program. Now inside our main function we have the variable declaration. We only need the integer age. That's the only piece of information that we're interacting with. We're going to ask the user to give us their age. We'll ask them, how old are you? And they will tell us their age in years. And then we're going to check to see if they're old enough. We're going to check if the age they gave us is greater than or equal to the limit that we've defined. And if so, then they can apply for their license. And if not, then they have to wait some number of years. So they have to wait X more years, where X is equal to the limit minus the age, so 16 minus the number that they gave us. Now when we're testing programs that have conditional execution, we need to make sure we test both versions. So when we run the program, we want to put input that will generate a true, and then we run it again with input that generates false. So if we put in input that should generate true, like 17, it'll say yes, you can apply for your license. Then we're going to try it with input that's definitely not true. It's going to say, sorry, you have to wait 4 more years before you can apply. And then we're also going to check our edge case. 16 is right on the edge. So we're going to check 16. It says you can apply for your license, which is true and intended. So of course, we know that actually getting your license is a bit more complicated than that. For the sake of our examples, we're going to add in just one more constraint, which is that you have to have 50 hours of practice time. Which is one of the constraints here in the state of Florida. You have to practice for 50 hours, 10 of them have to be at night, etc. So now we want to be able to check to see if age is greater than limit and their number of practice hours is greater than 50. So we'll use these compound Boolean expressions. There's 3. The first 2 are binary expressions, meaning they apply to 2 things. So and or. Not is a unary operator, meaning it only applies to one thing. We're going to look at their truth tables to see how they work. So here's and first. Now the way and is set up is we'll separate 2 conditional expressions with the and symbol, which is 2 ampersands next to each other. And remember, each individual conditional expression evaluates to true or false on its own. And this table describes the output we should get from the compound. So if both conditional expressions, both conditional expression 1 and conditional expression 2 are both false, then the and is false. If either one is false, then the result is false. In order to get true from and, both conditional expressions have to be true. So both this one and this one have to be true in order for us to get an overall result of true. So let's go ahead and try that out. Let's add practice hours to our program. And now in addition to asking how old they are, we'll ask them how many hours driving practice that they've completed. So we'll ask them both questions, store their input, and now in order to apply for their license, they have to meet both conditions. They have to have age over the limit and hours greater than or equal to 50. And if they meet both conditions, then they can apply for their license. And if not, I'm going to take this out for a second. We'll bring it back here in a minute. And right now, we'll just say, sorry, you cannot apply. And we'll come back in with some specifics here in a second. So now when we test, we've got to test a couple of different things. We've got to check a case that we know is true. So someone who is the correct age and has enough hours of practice can apply for their license. Someone who is not old enough but has been practicing still cannot apply. Someone who is old enough but hasn't been practicing enough cannot apply. And of course, if neither condition is true, then they can't apply. Okay. So let's suppose that the user has held a license in another state. We could add that as one of our requirements. You don't have to apply for your license in Florida if you already have one somewhere else. And this is going to let us check out a new thing, which is character input. So we're going to create a character called ANS for answer. And that answer is going to be yes or no, using Y for yes and N for no. And when we scan that in, let's make sure that we use the correct percent code. This is not one that we've used very often, so we're going to use %C for character and store their response in answer. So now when we're checking our conditionals, we need to know if they're over the correct age, and they've had enough hours of practice, or they already have their license somewhere else. So let's look at or. Or is another compound Boolean. So we're going to create or by having two conditional expressions separated by the or symbol, which is two vertical lines. On a standard QWERTY keyboard, that's directly under the backspace. And in an or, if either conditional expression is true, then the answer is true. So one or the other. So if this one is true, or this one is true, or both are true, we'll get true for our answer. But if both are false, then the result of the or is also false. Okay. So we can use that over here. We can say if age is over the correct limit and hours of practice are the right number, or they've held a license in a different state, then they can apply for their license in Florida. So there's an order of precedence here, and has a higher precedence than or, so we're checking these first. But if we want to make that explicit, then all we have to do is encapsulate this in a set of parentheses. And that helps us visualize the expression between these two parentheses forms a conditional expression that we or with this one. And inside the set of parentheses is another compound Boolean expression that has and. So now if either this whole expression or this one is true, then they can apply for their license. Inside the set of parentheses, both have to be true in order for the overall expression to evaluate to true. Now before we run our program, there's one more thing to check. Characters sometimes behave a little bit strangely in C programming, so just to make sure that everything's working correctly, we're going to go to their scan statement and put a space in front of the %C. So now we'll check all of our conditions. So suppose we have somebody coming in from out of state. They're old enough, got plenty of hours of practice, they've held a license somewhere else, they're allowed to apply for their license in Florida. Let's check a couple of other things. Let's say maybe they haven't had a lot of experience driving, but since they've held a license somewhere else, they still get to apply for their license in Florida. If they've not held a license in a different state, then they can still apply in Florida by meeting the minimum requirements of being old enough and having X number of hours. But if they're not old enough and they haven't held their license in a different state, then they have to meet both of those conditions because it's an and if they don't meet either one, then they cannot apply for their license yet. So right now, if they can't apply for their license, all we're telling the user is, sorry, you just can't apply for your license. So let's add some more context to our else statement. We'll go ahead and tell them what they're missing. So we'll go into our else statement and account for missing age and missing hours. And we're going to rearrange these a little bit. So first we'll say, sorry, you can't apply for your license, and then we'll figure out what is wrong. That means they can't apply. So if they're not old enough, we'll print out, sorry, you have to wait however many more years are left. And if they're missing driving hours, then we'll print out how many more hours of driving practice you need. And this is a nice reminder that even though you can have if-else statements, that doesn't get rid of the ability to have ifs by themselves. So now we have an if statement of if they're missing age, you must wait this many more years. And if they're missing practice, then you must practice this many more hours. And that way, if they're both true, it'll print out both statements. All right, so let's take a look and see what that would look like. Say they're missing hours. Now we'll say, sorry, you cannot apply for your license, and you need 30 more hours of practice. And now let's check age. So now they're not old enough, even though they've been practicing, presumably on a learner's permit. They have to wait until they turn 16 to apply. And if they're missing both, it'll give them both messages. You cannot apply for your license, you have to wait until you turn 16, and you need 10 more hours of practice. These two if statements here are inside this else statement. And so we've indented them to demonstrate that. But since they're inside, they're called nested. These if statements are nested inside that else statement. Our final compound operator is not, and not just negates the expression, so that if it was true, it becomes false, and if it was false, it becomes true. So to use not, we use this exclamation symbol before the conditional expression, so that if it would have evaluated to false, not false is true. And if it would have evaluated to true, not true is false. And we can use that to be clever with some of our conditional expressions. For example, not age greater than 16 is the same as age less than or equal to 16. In our next video, we'll look at some common errors that people make with if statements and how we can fix them. I'll see you then.